So just after yesterday's video, I was playing around with a cable like this and just joining wires up, and I ended up with a double up on the wave, and so I didn't touch anything. I came back to it when I had a fresh mind and would draw it out, see what I actually did before I pulled it apart and lost the effect. So this is what was going on, so we're calling that 0 and counting up as the coils on the stack go. So signal input, that's the signal input, and the scope leads there are currently across 1 and 4. I've labelled the ends of the wires more clearly when I wired it up. Previously I just put some lines, so 3 lines on coil 3, 1 line on coil 1, but it's just been painful, so I put little tags on there to make it just easy to sight them. So yeah, this is what was going on. The inside of coil 2 was connected to the outside of coil 4, so let's just follow along and I'll show you what happened. So there's where are we on? I'm probing 4 anyway, so we'll see the effect. Okay, so inside to outside. So number 4 inside shares this one here. Number 4 inside to the outside of number 2, which is down over here. And so there's the other 2 and 4. There's the other 2 up here. So just a reminder, the cooker's not running. This is playing with the coil on the cooker where it would be working and getting a feel for what's going on with its coil behaviour, phases, all that sort of business. Right, where's 2 gone? The other end of 2 is... no, the other end of 4. 3, 4. Alright, now look at that. Waves doubled up. 180 degrees out of phase. Now that's not what I had yesterday. Maybe it's just a matter of which way the probes are around. But that doesn't make sense because they were in phase before. I'll just break that circuit again. So they're in phase. Now they're not. So yesterday I had the phase that they were in phase. Maybe I can just move that to the other end. Hang on. Okay, I'll flip the oscilloscope probe around and it's showing in phase now, but let's see what happens if I break this 2 and 4 arrangement. See, they're still in phase. How can I measure it out of phase and in phase when disconnected looks the same? I don't understand. Anyway, that's what's going on. Yeah, this is a triangular waveform going into, by the way. Let's see what sine looks like. Should be fairly similar. Just a bit taller. Oh no, that's square. Geez, it really smooths out a square wave. Look at that. Square, triangle, sine. my cooker was going to run at 14 kilohertz. So this is where having a control over the ZVS switching would be fantastic, because watch what happens if I just dial it down, because it'll be a bit too tall. I'll take it into resonance. There we go. Oh, where was the hump? How come the other day it was a different resonance? Maybe I wasn't hooked up on the cooker. No, I was hooked up on the cooker. Oh, I know, I was measuring it on that pan. I had the coil sitting in there. Well, that's pretty much on song then. That's a lucky accident. They're both on the same setting. 200 millivolts per division. Input is 1.1 volts RMS. Thanks for watching.